A very good morning to all present here. I welcome all the dignitaries and the participants to the second day of the 5-day FDP on evolving role of AI and ML in state-of-the-art research and development, sponsored by AICT Training and Learning Academy, organized by Department of Computer Science and Engineering. We would like to welcome all once again to the second day of our FDP program. So today we would have 3 sessions throughout the day. And before I start, I would like to remind the participants once again regarding the attendance form. The link for the form would be shared in the Zoom chat box only, and it would be active only until half an hour, that is from 3 to 3:30 p.m. So please keep an eye on the Zoom chat box. So here we have our speaker, our eminent speaker for the day, Mr. Sabyasachi Mukhopadhyay. So sir would be taking up the topic of natural language processing today. So we would like to welcome you, sir, wholeheartedly to the session. Of Business Analytics and Statistics at School of Management Science, MAKAUT. He is University Course Coordinator of BBA and MBA in Business Analytics at MAKAUT. Mr. Mukhopadhyay is also the convener of Institute's Innovation Council at MAKAUT. Apart from being Kolkata lead of Facebook Developer Circle, he is the Google developer expert in machine learning and Intel software innovator. He was the former assistant professor of business analytics in postgraduate management studies at IIM Kolkata, affiliated to MAKAUT. He was also the visiting faculty of the analytics in postgraduate management studies at Symbiosis Center for Information Technology, affiliated by SIU Pune. Mr. Mukhopadhyay received MS in Physical Sciences from IISER Kolkata and was the topper of 2015 batch. He is the course curriculum developer, paper setter, examiner, and moderator of MAKAUT and SCIT Pune. He was the co-founder and chief research officer of Twillit MedTech Private Limited and currently involved in startup mentoring activities. Sir was project scientist at Nanoscience Technologies for a brief period of time. He was featured in the Facebook's special coverage, The Limitless, as one of the India's leading innovators and entrepreneurs of 2018. He has more than 15 publications, which includes patent, books, journals, and proceedings. His finding on AI-based retina disease detection and AI-based early-stage cancer detection has been highlighted in all the leading newspapers like the Hindus, the Times of India, the Indian Express, and many more. He received several international awards, which includes Best Research Paper Award, prestigious SPIE Photonics Educational Scholarship 2014, Most Inspiring Facebook Developers Circle Lead, that was for the two-time consecutively, and so on. Mr. Mukhopadhyay delivered invited talks in several panelists and was judged in several leading ITs, IITs, IISERs, and many more. He is also the TEDx talk speaker. I mean, he has been there for 2 times. So he has been a speaker in TEDx for 2 times. And Mr. Mukhopadhyay received an honorary mention in the government of official site of Embassy of India to Switzerland for his research. Sir is going to speak today on natural language processing today. And I would like to invite you again, once again, sir, to the event. Over to you now.
Thank you very much, man. Thanks for the generous introduction. And I am thankful to IEM Kolkata for inviting me. And definitely just one small correction I want to highlight that currently I am not affiliated with MAKAUT. I was affiliated with MAKAUT. So I just went back to my earlier institute, Bharatiya Vidyavan Institute of Management Science, as an assistant professor. So anyway, let me share the screen. So I hope the screen is visible to all of you. So yes, I would request all the participants to kindly open Google Colab. So you just simply search in Google. Kindly go to new notebook section of Google Colab. So here you can you can edit it and keep it like NLP 1 or something like that as per your wish. Okay, as in the title section of the Colab, where you can session wise you can update the title. And you see there are 2 portions. One is the plus code and plus text. And generally plus text, whenever we add some text, you can write it there. And the plus code, you can actually write the code. Okay. So basically what I will do, I will first explain a brief theoretical overview, and then we will execute the hands-on session. So nothing to worry about it. I will definitely share the notebook to the organizers. So they will distribute among all of you. So there you will get all the necessary theories and the coding part as well. Now during the session, what we will do, I will just explore some of the coding portion in the Google Colab, so which will give you the idea that how to evaluate the coding portion of the NLP part. Okay. So,
sir, may I interrupt a little bit?
Yes, yes.
Yeah, I think there's some, air noise coming up from the microphone.
Just a second. Okay, has the noise reduced?
Yeah, much better.
Okay. So what we will do, we will first make an overview on the theoretical part, and then gradually we'll execute the coding part in your Colab. Okay. So basically, first of all, we will see regarding the today's discussion that the word embedding part. Okay. So to talk about natural language processing, So it is required in terms of the, and as per the basic requirement of the human condition, or as per our knowledge. So a vast amount of the written text which are being generated on day by day basis. So you can see that there are rich amount of the text. If you look after the chat apps, emails, okay, product reviews, news articles, research paper, books, social media. So it is quite inevitable that to understand in terms of the making assistance or decision makings over the human languages. Okay, so in a what we can define for the NLP or natural language processing is that it is the interaction between the computer and human using natural languages. So in general, what happens that we generally use the natural language processing techniques in order to process and analyze the text, okay, which we are referring as the human natural language. So to understand the text, we can begin with its presentation, okay. For example, treating each words or subword as token, okay. So here what we will see in this particular tutorial, that the representation of each token can be pretended as a large corpus, okay. So corpus means collection of text here basically. So which can be done using word2vec, okay, glob or other subword embedding models. So after pretending, the presentation of each token can be a vector, okay. So for instance, vector representation of bank is the same in both the word sentence. If you see, go to the bank to deposit some money, or for example, go to the bank to sit down. So in general, I mean, in a more recent way, if you see the overall the pretending model to adapt the representation of the same token in different contexts, okay. So these are not the word2vec process is not the token sensitive, rather it's going towards the generalization, okay. In both the cases, if you see the use of the word bank in both the sentences, go to the bank to deposit some money, or go to the bank to sit down, in both the cases it is playing the same role, okay. So what is word embedding in general? For example, if we are talking about the word2vec, so in natural language, it's as we know that this is a complex system, okay, that we use to express some meaningful insights. So in the system, what's are the basically the basic unit of the linguistic meaning, okay. So as the name suggests, that word vector is a vector that can be used to represent word, okay, and it can be also bought as the feature vector of a word. So this technique of mapping words to vectors of real numbers is also referred as the word embedding. So over the last decade, if you see that embedding has become a pivotal part of the natural language processing. So if you may ask about that, why should not we are going with the one hot word vectors, okay, because it is quite easy to construction purpose. But in general, what happens that it is not a good choice, because one word vectors cannot accurately express the similarity between the words, because we find the similarity among the words with the help of cosine similarity in general purpose. But the cosine similarity between the one word vectors of any two different words is zero. So that makes difficult one word vector to accurately represent the similarity between the multiple different words. So that is the reason that we are not going with the one word vector. So rather we are putting emphasis on the word2vec. So word2vec is basically a method which is overcoming the shortcomings which we have from the one hot word vectors. Okay, so it can represent each word with a fixed length vector. Okay, and it can utilize the vectors for better indication among the similarity, okay, and the analogy relationships between the different words. Okay, so word2 vector can include both of the process. For example, it can be skipgram model. So in a shorter format, we call them as the SGMs, or it can be continuous bag of words. So continuous bag of words, SIBAO. Okay, so skipgram model in generally assumes that the context word generated based on the central target word. Okay, for example, father loves his son. So here we are basically considering the central word loves. Okay, and what are the context words? Father, his, and son. Okay, and we can also, in case of the SIBA, is also quite a similar process, but we exactly do the opposite. Okay, so from the central word is generated on the basis of the context word. Like the sentence I mentioned, that father loves his son. So basically here loves is the basically your central target word. So what are the context word? Father, his son. So from the given context word, you are basically generating the central word. Whenever the given context word, we are generating the central word, then this is a CBAO model. And if it is your skipgram model, then what will happen that your context word will be generated on the basis of the central target word. So central target word will be there, which will be acted as a reference, and on the basis of that, what you will do, you will generate the context word. Okay, so vice versa process. So what to beg method basically utilizing the methods like continuous bag of words and skipgram models. Okay, so these two process, and we are not going with the one hot vector method. Why? Because whenever we are going for the measuring the cosine similarity among the two words, okay, so that is landing up with 0. So which is making the process difficult. As a result, we are going with what to vec method. Okay, so this is the basic theoretical overview. And now the data set we are using for pretending the word embedding, that is that is basically your pen tree bank, okay, PTB data set. Okay, so what is the PTB data set? So this, it actually takes sample from the Wall Street Journal articles and includes the training sets, validation sets, and test sets. So in general, what happens that the task consists of the annotating each word with the help of the parts of speech. Okay, so parts of speech tag. So in the most common split of the overall corpus is that the section 0 to 18 is used for the training purpose, which is consisting of 38,219 sentences and 9,12,344 tokens. Okay, section 19 to 21 is all about the validation. Okay, so in the validation part, what will happen that 5,527 sentences are there and 1,31,768 tokens, followed by the sections from 22 to 24, okay, which are basically used for the testing purpose. Okay, so in case of the testing, there will be 5,462 sentences are there, okay, and followed by 1,29,654 tokens. So this is how in general formation of the split of the corpus took place in case of the PTB dataset formation. So the corpus is basically commonly used for the character level and word level language modeling. Okay, so let us first have a look at the packages and modules which are required for your experiment purpose. Okay, so let us go through that. So let me tell you that first of all, what we will do. So those who are very new to Python or Pythonic platform, okay, so for them I have added some notes on code. Okay, why we are importing certain things and all those things are there. Few highlights are there. So you can see there is in the notebook section there is a mention of the notes on code. Okay, so in case you are facing any difficulty, you can check out them and you can understand that why you are using certain modules or why we are using certain functions. Okay, and the rest of the codes are basically those who are from the computer science or IT background or from any other discipline who has a good coding knowledge, they can easily understand that part. So first of all, what we are doing, we are basically pip install, we are installing MXNet. So then followed by MXNet, we are doing D2L. So MXNet is basically your deep learning framework. Okay, and D2L is providing all the supportive version independent supportive assistance for the deep learning implementation of the MXNet. Import math, what does it do? Import math is a built-in module, okay, in any Python or Python related platform. So which can extend the list of mathematical function. Okay, import OS, you can understand that import OS module provides the function for creating and removing the directory or folders which fetching the contents changes or any identifying current directory. So it basically provides you all the support related to the operating system. Okay, And import random will definitely will help you to do the randomization steps in the Pythonic platform. And definitely the gluon is playing an important role, which is this is a particularly part of the interface which comes under the MXNet module, which basically fastens the process of the deep learning architecture without sacrificing the training speed. Okay. And definitely NP stands for the NumPy array. So once you run this chunk of the code, what will happen that you will be able to see the following outcome, that downloading the D2L module. And after the end of the download, you can see that successfully installed the current version. Okay. So what I'm doing, I'm just sending this chunk of code in your comment box section. Okay. So as I always say that this in the doing hands-on in the virtual mode is all about the interaction with all of our respected participants, respected faculties are there. So I would request all of you that whenever you are done with the running of the code, just kindly let me know that you have been successfully able to run the code, so such that I can move to the next part. Okay, so I request all of your kind and active participation such that we can move the process faster. Okay, so what I'm doing, I'm just sending the code in your comment box section. So kindly let me know if you are able to run it successfully. Okay. So I have sent you the code in your comment box section. So kindly run it and let me know if you have any difficulty or if you are facing any difficulty. So you see, in the left-hand side of your coding section, there is a run cell button is there. Once you aligned your code or you have pasted your code in your coding part, coding section of your Colab, just hit on the run cell button. So it will run and you will be able to see the executed code part. Once done, kindly let me know. So this is 9:50. I expect that by 9:52, all of you can execute that part. So I would request all the participants to kindly look after your comment box section. I have sent the code to your comment box, so I believe all of you can see it. So this is the installation of the required packages and modules. So I request all of you to kindly do it fast. Then we will move to the next part. Okay, so Somodip Ghosh sir already mentioned that he has completed that step. Thank you very much, Somodip Ghosh sir. So anybody else who has been able to complete it, kindly let me know. It would be good if I can get at least 4 or 5 responses. Then it will be easier for me to move forward to the next part. Thank you, Somodip Ghosh sir. Okay, so PS Raju sir has already highlighted. He has already completed it. Thank you, Raju sir. And if anybody else has completed it, kindly let me know. Okay, okay. Indumati Jagadishan. Indumati Jagadishan already has said that he or she has been able to successfully install it. So thank you very much. Thanks a lot. Okay, Binod sir already highlighted that he has been able to done it. So I believe that gradually all of you will be able to do it who has not done it. So let us move to the next part. thank you very much all for your kind responses. Thanks a lot. So now we will see the reading and pre-processing of the data set. Okay. So each line of the data set, if you see, that will act as a sentence. Okay. So all words in a sentence are separated by space. So in the word embedding task, each word is a token. So remember the terminology token. In a word embedding task, we are referring each word as token. Okay. So here you see that we are basically dealing with PTB. Okay, Pentry Bank. So in the PTB, what we are doing, we will first read PTB. So we are defining the read PTB function. So under that, we are defining data directory, okay, by assigning it with the d2l.download_extract with PTB link. Okay, then opening it with open wes.path.join. Okay, we are giving the data_directory link. Okay, and then we are defining the raw text, which is being which we are doing the file read comment. Okay, then what we are doing, we are basically returning it as the line.split for line in row underscore text split tab n. So it will, in the next line, what will happen is whenever you are writing sentences with calling the function with read_ptb, then what will happen? Then once you are printing the length of the sentence, you will be able to see that it has been downloaded, the data has been downloaded, and then you will get the number of the count of the sentence, length of the sentences. So it will be 42,069. Okay. So what you can do, I am just ending this part of the code in your comment box section, so you can easily run it. So I have sent this portion of the code in your comment box section. So kindly let me know if you are able to run it. Make sure that you have given the proper spacing. Okay, just look at the screen that you will be able to understand that how to give the proper spacing. Indentation in Python, indentation is very, very important. You see, in other programming languages, we give the indentation in terms of the making or looking the code much more elegant or stylish. But in Python, it is important. Although in Colab, it is the general benefit that in generally the cursor moves around. Okay, so if you are defining certain function, automatically at least one level of spacing will be given in the next line whenever you are typing the code. So make sure that proper spacing is given. Okay, proper indentation has been given in each line of the code as per requirement. Jyoti Sethi madam, I have already given the code in the comment box section. Kindly look after it. Okay, so already Pankaj sir has posted it again. Thank you, Pankaj sir. Thanks for your confirmation. Okay, so to all of you. So it is expected to get the outcome 42069. Okay, so I believe that gradually all of you are getting it. Okay. Thank you, Jyoti Sethi madam. Thank you very much. Thank you, Shamili madam, for your confirmation. Thank you. Of UNK. This particular token named UNK. Okay. What does it do? It basically represent the rare words. Okay, which has the frequency not greater than 10 times. So what we are doing to prepare the vocabulary, we are assigning the name as vocab. Okay. So D2L under the vocab. Okay, we are putting two arguments. One is the sentences, another one is the mean frequencies. So under the mean freq, we are defining it as 10. Okay, because we are counting that it is not going to exceed 10. Then what we are doing, we are basically printing the length of the vocab. So what will happen? You will get the vocab size 6719. Okay. So what I'm doing, just simple part of the code section. I am just sending you in the comment box section. Kindly incorporate it. So I have sent you the code in your comment box section. So kindly run it and let me know once you are done. So it's now 10 a.m. I believe that by 10 to all of you can do it. You will get the vocab size as an output. So here what we are doing, we are building the vocabulary with the word appeared less than 10 times. So which is being stored under the token, UNK token. So any preprocessed PTB data has this token part, UNK token, which represents the rare words or the lesser frequency words, which has frequency less than 10. Okay, minimum frequency is 10. So kindly notify me once you are done it. Okay, thank you, Somodip Ghosh sir. Thanks a lot. Pankaj Kesarwani sir, thank you very much. So you have downloaded the data. Now please kindly check the vocab size. So in the next part, I kindly look that I have sent that how to define the vocab, which consists of the rare words. Okay, less than 10 or minimum 10. So I have sent already this part in your comment box section. Kindly look. Okay, I am reposting it again. So if you are running it, you will get the vocab size 6719. Yes, sir. So to know the vocab size, you see, it will give you the result 6719. Just run this part of the code. Ayesha Amin madam, I already post the code in the chat box. Kindly look after it. I am again reposting this portion to calculate the vocab size part. I have again reposted in the comment box section. Just a second. I think some problem is going on now. Can anyone? I hope now everyone can see it. Jagdishan sir, I think you can now see it. Kindly look after it. Aisha madam already said thank you. So please take your time. Once you are done, just let me know. Okay. Oh, thank you, Indumati madam. Thank you. Just please take your time. Do it relaxedly. Okay. And let me know if you all of our expected participants. I am requesting to all of you that once you are done with that part, just let me know. Then we shall proceed to the next part. So you are doing one by one. So what I am doing, I am just sending data. So you have not got the first part. So what I am doing, So it may happen that some of. So what I'm doing, I'm just reposting the coding portion right from the beginning. Okay. So those who have already incorporated it, kindly wait and let our other participants to proceed further. So what I'm doing right from the beginning, I am posting it. Okay. So kindly look after your comment box section. I am just posting one by one. Okay, right from the beginning. In the first portion, what you are doing, basically we are installing all the necessary modules and packages. The second portion of the code which I sent you, that is all about the reading and pre-processing dataset. Okay. And then once you are doing it, run it, you will get the length of the sentences, that will 42069. And then finally, with the vocab size. The third portion of the code is all about the vocab size. If you run it, you will get 6719 as an output. Okay. So let me know once you are done with the vocab part. Once you have been able to complete till the vocab size part. Okay, just kindly notify me at the comment box section that all of you are being able to complete up to vocab size part. Thank you, Indumati ji. Thank you very much. Thank you, Dr. Aisha Amin. Okay. Thank you, Samili madam. So I believe that now it is quite understandable, and all the rest of the participants are also aligned with the progress up to the vocab size. Okay, most welcome, Aisha madam. So I believe that we can now proceed to the next part. So now we will talk about the subsampling. Okay. So in the subsampling, that in generally what happens that in the text data, okay, generally there are some of the words which would be very high frequency words. Okay, so what are those words? For example, in the so these are the in English, if we talk about the high frequency words, these are the very common high frequency words. So generally, whenever we are defining the context window, so it is always better to train the word embedding model. Okay, where there will be very lesser appearances of the high frequency words, or if we can avoid the high frequency words. So what type of words can be there? For example, low frequency words. Like if you look at the text, you can see that there are words like microprocessor. Okay, there are words like chip. So these are the words which appear at the same time. So you can consider those things for the training purpose of the word embedding model. So what happens that whenever we are training the word embedding model, we can perform this type of the procedure like subsampling on the word. So there is a very landmark paper written by Mikolov in 2013, which has highlighted the efficacy of the subsampling procedure in terms of the word embedding model. Okay, so for example, if you have the index to WI in the data set, okay, it will drop out at a certain probability. Okay, so what will be the dropout probability? How can you calculate the dropout probability? So P of WI is all about square root of max 1 minus max of 1 minus square root of T by function of FWI. Okay, so where you see the FWI is all about the ratio of the instances of word WI to the total number of words present in the data set. Okay, and T is the hyperparameter. So what is the value has been set for T? It has been set to 10 to the power minus 4 in this particular experiment. What we are doing, and we have made it fixed with the 10 to the power minus 4 value. Okay, so as we can see that it is possible to drop out the word WI, okay, in subsampling when the function of WI is greater than T. That means the higher the word's frequency, the higher will be its dropout frequency. So whenever we are doing the word embedding or building the word embedding model, our target will be to utilize the benefit of the subsampling model to drop out the higher frequency words. So as per the formula, if you see, developed by the Mikolov, which he has mentioned in his 2013 paper, that the more the frequency will be the words, okay, the dropout chances will be higher. Okay, so if you look at the formula that P of WI, okay, the WI is the word index. So the maximum of 1 minus square root of T divided by function of WI, 0. So this part we will basically incorporate in our through the Pythonic platform coding. Here we are using the framework MXNet for executing the code. So we are first of all defining the subsampling function. So what we are doing here, so subsampling there are two arguments will be there while defining the function. First of all, the sentence, and second one is the vocab. Okay, then what we'll do, we'll map the low frequency words into under the UNK token. So sentences, vocab, index to token. Okay, so what we are doing basically for TK in line, okay, and for line in sentences, we are then what we are doing, we are basically counting the frequency for each word. So what we are doing, we are basically assigning counter with D2L count underscore corpus, which is executed over sentences, and then we are taking the sum of the counter values which has been assigned under num underscore tokens. Okay, then we will see that return true if to keep this token during the subsampling. So what we are doing under that, we are defining keep token. Okay, so return random dot uniform under over the 0 and 1 on less than 2 math square root. That's the reason we have imported the math module to utilize this math square root function, math square root 10 to the power minus 4, because we have defined, if you see this particular formula, we have defined that T hyperparameter will be 10 to the power minus 4, this particular experiment. So that's the reason we have defining 10 to the power minus 4. And if you look after the formula, divided by counter token in num underscore tokens. Okay, as for the formula, you can see there, okay, which has been developed by one of the very smart data scientist Mikolov. We are following his step. Okay, so this is how it has been written under the code, and then we can do the subsampling. So a return function is applied over TK for TK in line if keep TK for line in sentence. Okay, then what we are doing, we are assigning the subsampling function, which consists of two arguments, sentence and vocab, under the subsample variable. Okay, so make sure that you are running this portion of the code successfully. I am sending this portion of the code in your comment box section. So I have sent this portion of the code in your comment box section. Let me know if you are able to run it successfully. Okay. So this portion of the code, we have defined the subsampling function, okay, and the overall subsampling procedure by following the method developed by Mikolov in 2013. So this was the formula, and this formula exactly what we have executed in the coding section, okay, where t is 10 to the power minus 4, and which has been divided by the counter token into number of the tokens, okay. So this is how we have executed the overall process, okay, to define the subsampling part. So in the subsampling, our target will be to reduce the high frequency words. So the higher will be the words frequency as per the formula, the higher will be the dropout probability. Okay, so that's all about the execution part in the subsampling section. Okay, so if you are done with the process, please let me know. It's to 10:14. I am expecting by 10:16 all of you can complete it. So just check, just look at the code and just align the line of the code with the spacing given in your comment box section. I repeat, in Python, there you may experience, for example, indentation error, because in Python it's a very spacing sensitive. Apart from the case sensitive language, it's a very spacing sensitive. In other programming language, what happens that you can align the spaces as per your requirement to make or to give the code a much more stylish or elegant shape. But in Python, there are some certain necessary for certain spacing. So that's the reason you have to maintain those indentation spacing, especially defining the functions, giving some conditions. So you have to put proper spaces. So please follow the proper spacing as aligned in the, or as you can see in the screen. Okay, so it will help you to run the code smoothly. So I believe some of the responses has already come up in the comment box section. So let me go through them. Okay, completed. Okay, thank you, Somili madam. Thank you, Aisha madam. Okay. Okay, Somodip sir, thank you very much. Pankaj Kesarwani sir, thanks a lot. So all of our respected faculties are participating actively. I am very much thankful to them, because doing things online, remote mode is not very easy until or unless the active participation is there. So I am thankful to all of them, and also requesting all of you that if you face any difficulty or any problem, just let me know. I am waiting another 1 minute. Okay, then I will move to the next part. So it's 10:16. So we'll wait for a few more seconds and then we'll move to the next part. In meanwhile, if you face any difficulty, let me know. Otherwise, we'll consider that you have been able to run it smoothly. So I can see a few more responses. Very informative. Vivakar Pathak. Okay, thank you very much. Thank you very much, Vivakar sir. Always your faculties like you, it is important to let us know about your precious feedback, because in this current scenario in 21st century, all of us are the learners. None of us are the Pluto or Aristotle. So it's all about peer-to-peer learning, sharing our knowledges, exchanging our knowledges. So your feedback is very precious. Thanks a lot, sir. Thank you very much. So I am moving to the next part. So now what we'll do, we'll basically compare the length of these sequences before and after sampling. So already we have executed the subsampling part. So we will see the sequence lengths before and after subsampling. So you can see that once you run this portion of the code, you will be able to see that the subsampling significantly has reduced the length of the sequences. Okay. So what we'll do, we will basically compare the original and subsample part, and we'll see that how much it has the created effect on this sequence length. Okay, so you can see the X label we have done with the tokens part sentences. Y labeling we have done using count, and we have given the toLegend in order to mark the origin and subsample portion. Okay, so I am sending this portion of the code to your comment box section, okay, such that all of you can run it successfully. So I have pasted this portion of the code in your comment box section. Kindly let me know if you are able to run it successfully. So I am requesting all the respected faculty members to kindly look after this portion of the code, and you will be able to see this type of the graph, which you can see in the screen. Okay, so there you can see there is a comparison has been made for the original and subsample portion. So in the x-axis, you can see the tokens per sentence. Okay, in the y-axis, you can see the count. Okay, and the marker is giving the legend has been indicating the original and subsample comparisons. So it is quite understandable that with the help of the subsampling, we can able to reduce the sequence length. Okay, so let me know if you are done with it, and it's 10:19. So I am expecting by 10:20 all of you can be able to run it successfully. Already our respected faculty members are posting their precious comments. So let me check. Okay, so Bibakar Patak sir already has sent his confirmation. Thank you, sir. Samili madam, thank you very much. Graph is coming. Okay. Already Pankaj Kiswarani sir, thank you very much, sir. Somodip sir, thanks a lot. Okay. Indumoti madam, thank you. Aisha Amin madam, thanks a lot. Thanks a lot. In case I miss out somebody's name, kindly forgive me. So all of you have already highlighted your appreciation, your comment that all of you have been able to run it successfully. So thanks a lot. So let us wait for a few more seconds and then we will move to the next part. Meanwhile, if anybody has faced any difficulty, kindly let me know. So it will help us in the smoother progress of this session. So let us wait for a few more seconds, then we shall move to the next part. I believe that the rest of the participants, respected participants, are being able to execute the code in a smoother way. So let us move to the next part. Now, after the plot we have generated, we will see that for individual tokens, the sampling rate of the high frequency word D is less than 1/20. Okay, so you will see, just a second, a few more comments has already arrived. Okay, Sujata madam has got some error. Madam, I think you have missed out the sentence part. Okay. You have joined sometime later, I guess, or you have somehow you have missed out that part. So you have I am believing that you have installed the package part. Okay, and then you have completed the reading and pre-processing of the data set. So what I am doing, I am believing that you are done with your all the necessary installation of the packages and the module part. I am just sending you the reading and pre-processing of the dataset part. So kindly just run it fast. Then you will be able to run the rest of the portion. You have to require first run the reading and pre-processing of the dataset properly. So I have sent that portion in your comment box section. Make sure that you have been able to run it successfully. Okay. Followed by what you have to do, you have to check the vocab size. Okay, so I am sending it again in your comment box. So those who have already incorporated, kindly just wait for a few minutes. Okay, and then you have to define this subsampling part. Okay, and under the subsampling, you have these sentences and vocab. So if you have been able to run it properly, you will be able to see you will be able to define the subsampling procedure, where we are considering two argument sentences and vocab, which is very, very important to see the subsampling effect before and after, okay, in order to reduce the high frequency effect. We are doing subsampling in order to reduce the high frequency effect on the word embedding procedure. Then after doing that, then you just run this plotting portion. Make sure that you are not missing out any chunk of code. Okay, please follow it sequentially. I believe you have missed out some portion during running of the code. Make sure that you are looking the comment box synchronously and just pasting the chunk of the code in your Google Colab with proper synchronization. Otherwise, you may miss out some important arguments or some important functions, which will not be able to give you the proper outcome in terms of the plot, which we have seen. I believe now it should run. So now we will see that for the individual token, now we will look up at the individual token wise performances. So in case of the individual token wise performances, the sampling rate of the high frequency word D will be less than 120. So how can we check the individual token performances? So what we are defining here, we are basically defining a particular function, that is compare counts, okay, where the argument is token. So we will see the different perspective, okay, defining the compare counts under the different conditions, okay. So what we will see that hash of D before and after, these two portions we will tally. So what we are doing, I am just sending this portion of the code, which will return the compare of the count of the before and after. So before means before sampling and after means after subsampling procedure. So before subsampling and after subsampling, how you can see the effect. So you will be able to see that the high frequency word D has reduced less than 120, 1 by 20. That means 1/20th part it has reduced. Okay, so that's a huge reduction. Just a second. Some comment has arrived. Done, sir. Okay, Raju sir. Okay, thank you. Sujata Kondekar, thanks, sir. Most welcome. So what I am doing, I am sending you this portion of the code. Just see how the subsampling is affecting this portion. For example, the high frequency words like the has been reduced more than 1/20th part than the earlier of the subsampling. Okay, so this is, you can see the blessings of subsampling method, which is being able to reduce the high frequency words in a large extent. Okay, so Somodip sir already has sent his confirmation. Done, sir. Thank you very much, sir, for your continuous support. So it is now 10:26. So we will wait for some more, 1 more minute, and then we'll proceed the next part. Thank you, Pankaj sir. Thanks a lot. Thank you. Okay, Ayesha madam, Samili madam. Okay, almost all of you are getting the nearby. Everybody is able to reduce it nearby 1/20th part before and after subsampling in case of the keyword. Sorry, the token. Okay, so Indumati madam, thank you very much. Okay, already all of you have been able to done it. So let us wait for a few more seconds, and then we will move to the next part. So I believe everybody has been able to run this portion of the code, okay, where you will get the before and after subsampling count of the token D, okay, which is a high frequency word, and we are reducing it at the rate of 1/20th than its earlier occurrences in the sentence. Okay, so Raju sir, thank you very much. Pankaj sir, thank you. Already everybody is sending their success of executing the code. So it's now 10:28. So I believe all of you have done it. You should move to the next part. So now we will see that it is the part of the high frequency. So we have seen that it has reduced 1/20th level. Now, what will happen if you are doing with the low frequency word? Okay, for example, join. So that's the thing we require to see. So we will execute the same function, compare counts. Already we have defined the compare counts function over the token argument. So we will now replace the token the with join. Okay, and we will see what is the performances of the low frequency word. So ideally it should preserve before and after sampling. The low frequency count of the low frequency word should be preserved. So in my system, it was showing that the before it is 45 and after it is 45. So it has been preserved. So let's see all of you can experience it. So I am posting the code in your comment section. So already it has been sent to all of you. Kindly check. Okay, and let me know. So in case of the low frequency word, the count should be preserved before and after subsampling. And let me know, I believe all of you should experience the same thing, that before and after subsampling, the count should be preserved. So what we have done, we have just replaced the with join, which is a low frequency word, and we are checking the count that before subsampling and after subsampling. Okay, so thank you, Aisha madam. So it actually implying that the count has been preserved for the low frequency words. Okay. So the count has been preserved for the low frequency words. So Aisha madam already has sent her input. Okay, so Somodip sir also, thank you very much, Somodip sir. So he has also been able to successfully check that before and after subsampling, we are being able to preserve the count. Okay, Pankaj sir also has sent his consent that he also has been able to check that total count is being preserved for a low frequency word like join. Thank you, Pankaj sir. Samali madam has also has sent her precious feedback. So anybody else who has been able to run this portion of the code successfully, where you can check the compare counts for the word join, for the token join, okay, which is a very low frequency word. Okay, done. Sarindumati madam also has been able to check it successfully. Okay, so it's 10:30. I believe that if we wait for a few more seconds, all of you will be able to complete the part. Then we shall move to the next part. Thank you very much for all the respected faculties who are continuously helping me to move forward. Okay, so let us move to the next portion. If anybody of you has felt any difficulties, let us know or let me know. Now, at lastly, what we'll check that mapping each token into index to contrast or to construct the corpus. Okay, corpus means collection of the text. So basically, what we'll do, we will define corpus with the vocab line for line in subsample. Okay, and we are putting some index. Okay, so what are the corpus index we are giving? 0 to 3, that means 0, 1, 2. In Python, 0 to 3 means 0, 1, 2. Okay, it will take the index value. Outcome will take the index value 0, 1, 2. Okay. So let me send you this chunk of the code to all of you, where we have completed the indexing to construct the corpus. Okay, and we are constructing the corpus for the index value 0 to 3. That means that the outcome, the corpus structure, the outcome you will get 0, 1, 2. Okay, 0, 1, 2, index 0, 1, 2. In Python, 0 to 3 means the last one will not be counted. You will get the, if you are assigning 0 is to n, you will get the outcome 0 to n minus 1. So here you will be able to see the outcome 0, 1, 2 indexing. Okay. 3 indexing, you will get 0, 1, 2. It's a 0 index language. Okay, Python. So 0, 1, 2. This is the outcome. Previous step code we did not get, sir. Sir, we are basically defining the corpus. Okay, corpus means the collection of the. Okay, thank you, Somodip sir. Already you have done it successfully. So corpus means collection of the text. So what we are doing, we are putting index on constructing the corpus. Okay, thank you, Pankaj sir. So what we have done, that we are building the corpus. Okay, and the index has been given 0:3. Thank you, Aisa madam. Already you have done it successfully. So once you are running it, you will be able to see the comma separation between the square brackets. You will get 3 outcomes. That means first one 0, second one 1, third one 2. These 3 outcomes you will get 0, 1, 2. Because we are taking the corpus index 0:3. Now what happens that in Python, if you are putting index 0:n, your outcome will be 0 to n minus 1. Okay, indexing level will be 0 to n minus 1 at the outcome. That is what you are seeing. Corpus is 0 to 3. Okay, and at the outcome, what you are getting? You are getting 3 index 0, 1, and 2. These 3 square bracket separation you are getting. If you are counting each of the square bracket outcome, first one is 0 index, second one is first index, third one is the second index. So 3 index values you are getting. So you are basically indexing the corpus portion. Is it clear now, sir? So most of all of you have already done it. Samili madam, Aisha madam, okay. Somodip sir, thank you very much. Okay, Raju sir, thanks a lot. So we shall move to the next part. I believe all of you have already done it. It's now 10:34. Okay, so let us wait for a few more seconds in case anyone faces any difficulty. Otherwise, we'll move to the next part. So indexing to corpus has been completed. This particular step has been completed. Okay, thank you, Indumati madam. So index to corpus text has been, this particular step we have already completed. So we'll move to the next part. So let us gradually move. I believe everybody has already executed that part. Now what we will see, basically, now loading the data set. So next, what we'll do, this part, basically we shall read the corpus with token indices into data batches for training purpose. Now we are gradually moving towards the training task. So extracting the central target words and the context word. So let me just define it again. For example, what we are considering as the central target word, father loves his son. Now you see what is the objective here, the father and son relation. Here the central word is serving the objective loves. Okay, and what are the other context words? For example, father, his, son. These are the context words. Okay, so in generally what happens that we use our words with a distance from the central target and the context word in terms of the context window. Okay, so we put some context window size. It can be of 2 words, it can be of 1 word. Okay, so our target will be that the distance should not exceed that particular context window size. Okay, so basically what will happen then, the following section, what we will do, we will define the function. Okay, where we will take the few arguments under the, for example, def, get, centers, and context function we have defined in the coding portion, where we have taken few arguments. So for example, corpus and maximum window size. Okay, so after doing that, what we will check that whether it is uniformly and randomly samples an integer. Okay, where if we put the context window size between integer 1 and the maximum context window size. Okay, so this what we are doing, we are basically checking that each sentence needs at least 2 words from a central target word. Okay, and a context word pairs. Okay, so that's the reason what will happen, that length, what we are defining, if length less than 2, then continue. Okay, then centers equals to centers plus line. Okay, and then what we are doing, we are putting the context window centered at I. So how we are defining it for I in range length of line. Okay, then we are defining the window size, random.randint. Under that function, we are defining 1, max window size. As we have defined it, that we are uniformly randomly samples an integer to be used as the context window size between integer 1 and maximum window size. So as per the written in the text, we have defined that window size equals to random dot landing 1 comma max window size. Okay, and then what we are doing, we are putting the indices under the list function and then we are defining range max 0 comma I minus window size. Okay, and minimum length line comma I plus 1 plus window size. Okay, and then what we are doing, we are excluding the central target word from the context word, indices dot remove I. Okay, and finally what we are doing, context dot append line idx or idx in indices. So then we are calling the return centers and context. Okay, so this is all about getting the output in terms of the what is the center word and what are the context word. Okay, so there are two arguments which are playing an important role. One is the corpus. That's the reason we have put the indexes over corpus. Okay, earlier step, and then putting the maximum window size. Okay, and we have put some conditions. For example, that while defining the window size, what we are doing, we are putting the randomization, what we are doing uniformly and randomly samples an integer where the context window size should lie between integer 1 and the max window size, or that means the maximum context window. So this type of the help of this type of conditions, we have defined the overall function to get the center and the context. Okay, with the help of that, we will be able to get the center and the context words. Okay, so what I am doing, I am just sending you this portion of the code in your comment box section. Let me know. I believe that all of you should successfully run this portion of the code. Make sure that the spacings are given properly, because whenever you are lifting the code from the comment box section, make sure that you have been able to give this proper spacing. Make sure that the indentation has been given properly. So it's 10:40. I believe that by 10:42, all of you should be able to complete this portion. Then we shall move to the next part. Kindly keep me acknowledged that if you are being able to run it successfully. So I believe the respective faculty members already have started. Okay, execution. Okay, thank you, Somudip sir. Thank you, Aisa madam. Okay. Thank you, Pankaj sir. Thanks a lot. I am requesting rest of the participants to kindly let me know, such that we can move to the next part. Muhammad Khaja sir, thank you. Thank you, Muhammad Khaja sir. So let us wait for a few more seconds and then we shall move to the next part. Thank you, Indumuthi madam. Thanks a lot. So it's now 10:42. So I believe that all of you have been able to run that portion successfully. In case anybody faces any difficulty, kindly let me know. I believe I should move to the next part. Raju sir, thanks a lot, Raju sir. So now what we'll do, we will create an artificial data set containing 2 sentences. First sentence comprises of 7 words and the second sentence comprises of 3 words, okay, respectively. And then we are assuming that the maximum content window is 2. Okay, now we will print all the central target word and their context word. Okay, so what we are doing, we are generating artificial data set containing 2 sentences. Okay, first sentence consists of 7 words, second sentence consists of 3 words. Okay, and then what we are doing, we are assuming that our context window is of size 2. Okay, and now what we'll do, we will check and print all the central target words and their context words. Okay, so you see that tiny data set, we are just given this representative data set named tiny data set. Now under the list, first case we are putting the range 7. That means what? Range 7 means 0, 1, 2, 3, 4, 5, 6. These 7 numbers. Okay, 0, 1, 2, 3, 4, 5, 6. And then we are putting 3 more words. Okay, so what we are doing, comma list range 7, 10. 7, 10 means what? Like I told you that if we are putting the range up to 10, then it will count up to 10 n minus 1. Okay, that means if it is 10, then it will count 10 minus 1, that means 9. So rest of the section it will have 7, 8, 9. Okay, and what we are doing, that assuming the context window is 2. So printing the data set, comma tiny underscore data set for center, comma context in zip, get centers and context function, which we defined earlier section, that to get center and context function. Under that we are taking 2 arguments. One is the tiny data set and another one is the context window. If you go back, see what is the definition of the earlier function: get centers and context corpus, comma max window size, max context window size. So corpus means the tiny data set here, and max window size is 2, as per definition, as per defined by us, right? So you see what we have defined. For centers and context in zip, get centers and context, under we have defined these 2 arguments. Tiny data set, arguments has been replaced with parameters, tiny data set, and 2. 2 means that particular considered with maximum context window size. Then what we are doing, we are printing centers and context. Okay, so the structure will be like center, okay, center number, then as context number. This is the structure. That means printing the output means there will be appearances of the string or character, center with the center value, as context with the context value. So data set, this is the given data set. After running the code, you see 0, 1, 2, 3, 4, 5, 6, and 7, 8, 9. So center 0 as context 1, 2, because we are starting from 0. We have the maximum context window 2. So if center is 0, what will be the context? 1, 2. If center is 1 as the context, what will be the context? If center is 1, we have the maximum window size 2. So below 1, we have the only one option, that is 0, because we are starting from 0. And above 1, how many options are there? 2, 3. Okay. Center 2 has context. Now 2, below 2, there are 2 options, 0, 1. And above 2, how many options are there? 3, 4. Okay, because the window maximum context window size is 2. So above 2, we can take 3 and 4. And below 2, there can be 0, 1. Center 3 has context 1, 2, 4, 5. Why? Because below 3, how many options are there? 0, 1, 2. Now we can't consider 0 because maximum context window size is 2. So you will take 1, 2. And above 3, how many options you can take? 2, because context window size is 2. 4, if we are taking 4 has context, 2, 3, 5, 6, quite evident that above 4, you can only take 5, 6 because maximum size is 2. Below 4, 0, 1, 2, 3, these are the possible options. Now 0, 1 should be dropped out because your window size is 2. So immediate neighborhood are 2 and 3. So you will take 2 and 3. Okay, 5, it is the same case because you see in case of the first sentence, we have the bandwidth between 0 to 6. First sentence, we have the word 0 to 6. So 5, in case of the center 5, we will have the immediate context. If we consider, we can take 6. Okay. Now, for example, if we go after the 6, we can only take 5. Okay. So in this way, different options have been taken. Okay. So maximum window size is 2. Either you can take maximum 2 context or you can consider 1 context. Okay. So for example, for 7, you can take 8. Okay. For example, 8, you can take 7 and 9. For 9, you can take 8 because in the second word, which is ranging from 7 to 9, okay, we are considering and checking for each of the center words, which are the possible contexts. Okay. So you can't go beyond 2. Okay. You can't go beyond 2 because your maximum context window is 2. So I am posting this particular portion of the code in your comment box section. Just check it. I believe all of you will be able to run it successfully. Let me know. So it's now 10:49. I believe that by 10:51, all of you will be able to run this portion of the code successfully. So let me know. I believe this portion is now quite clear to all of you. If you are done with the steps, kindly put your acknowledgement in the comment box section such that I can proceed to the next part. So already our respected faculty members have started commenting. Done, sir. Thank you, Indumati. Madam, thank you, Pankaj, sir. Thank you, Somodeep, sir. Thank you, Aisha, madam. Thanks a lot. So let us wait for a few more seconds and then we should move to the next part. Okay, so now what we will do in the next, as a part of the next part, that we will set the maximum context window size 5. Okay, and we will capture or we will extract all the central target words and their context words in dataset. So what we are doing here, we are utilizing the earlier defined function that was get, centers, and context. Okay, there basically corpus will remain same. And we are putting the maximum context window size as 5. And what is our objective is to capture or extract all the centers and their context words. And then what we will do, we will just check the length of all the centers. Okay. So you can see in my case, I have got the number 3,52,851, 352,851. This is the count of all the possible centers. Okay. So I am sending you the code in your comment box section and requesting all of you to check that for a provided context window size, maximum context window size 5, can you extract all the necessary central target words and their context word in the given data set. Okay. So posting it in your comment box, kindly let me know if you are being able to run it successfully. Okay, so please check that whether you are getting the length of all the centers or not. Provided you have the context window size 5, our target is to extract all the central target words and their context words from the data set. And to check the length of it. Okay, so all of you are gradually getting. Okay, great. Thank you, Pankaj sir. Thank you, Aisha madam. Thank you, Somodeep sir. So it's 10:53. We will wait for another 1 minute. Then at 10:54, we shall move to the next part. Oh, thank you, Indumati madam. Thanks a lot. Now, let us discuss about the negative sampling. So in generally, we use negative sampling for the approximate training purpose. Okay? So for a central and context word pair, we randomly sample K noise words. So for example, K in 5, we have considered in case of our experiment purpose. So according to the suggestion given in word do paper, that the noise word sampling probability PW, if we consider it as the PW, okay, which is the ratio of the word frequency of W to the total word frequency raised to the power 0.75. Okay, that was the Mikolov paper in 2013, one of the landmark paper, which has defined the word to paper. I am repeating that if the noise sampling probability PW is the ratio of the word frequency of W to the total word frequency raised to the power 0.75. Okay. Now we first define a particular class to draw a candidate according to the sampling weights. Okay. It catches a 10,000 size random number bank instead of calling random number choices every time. So what is the utilization? It catches 10,000 random number bank instead of calling random choices every time. So first case, class random generator, where random integer, we are drawing random integer 0 to n according to the n sampling weight. So definitely what we will do the def INIT, okay, initialization, where the first argument is self, comma, sampling weights. Now you see that for your understanding purpose, I have added one note of code in this portion, okay, where I have defined why we are using the INIT, what is the purpose of it. It is the result method in Python classes, which you can consider as the constructor for the object-oriented concept, okay. So this method is called when an object is created from the class, okay. So it allows the class to initialize the attributes of a particular class. And self, what does it imply? Self represents a particular instance of the class. Okay, so by using the self keyword, we can access the attribute and methods of the class in the Python. Okay, so it binds the attributes with the given argument. So that was the two part we have discussed. Okay, one is INIT, which is doing the initialization and basic constructor of the object-oriented concept. Okay, so it initializes the attributes of a class, and what is the self? Self basically the instances of the class. Okay, so which can access the attributes and methods of the class. So that is why we have defined those things. Just a second. Here, and then we have defined the self population with the list function applied over the sampling weight, followed by the range and by calculating the range and length of over the sampling weight. And then what we have done, the sampling weight has been assigned to self.sampling underscore weights. Okay, we have initialized self.candidates and we have put self.I equals to 0. And then what we have done, we have defined another function that is draw self. Okay, so under that we have define the length of the self.candidates. Okay, then we have made the utilization of the self-dot candidate in terms of the apply the random choice function over self-population weight, and K equals to 10,000 C, that it catches 10,000 random number bank instead of calling random choices every time. That's the reason K equals to 10,000. Then again, self.I initialization at 0, self.I equals to I plus 1, then returning the self.dot candidates at self.I minus 1. Okay, then we are putting the generator by taking the random generator function 2, 3, 4. Okay, here what we are doing, we are generator draw, applying the generator draw for in range 10. Okay, under the 10 range, we will count, okay, all the random number generator. Now you see that random number generation has been made between the count 10. So we got some numbers 1, 0, 2. In this way, we have generated some random generator here. Okay. So first of all, what we have to do, we have to generate the random number. Then we will get, how can we get the negatives? That means we are looking up at the noises in terms of the negative frequencies. So all context, we are defining the get negative function. Under that, we are defining all context, corpus and K. Okay, we are defining counter with d2l.count corpus. Then what we are doing, we are defining the sampling weight. So you see the formula, I mean, as per the definition is given that noise watt sampling probability PW is the ratio of the watt frequency W to the total watt frequency raised to the power 0.7 as per the Nikolov description. So it has been given there. Counter I to the power 0.75 for I in range length of the counter. We have defined accordingly. Then what we have done, all negatives and generators are assigned with the random generator over applied over sampling weight. So for context, in all context, negative has been initialized. Then all, while the length of the negatives less than 2 length context into K, we are defining generator.draw into under the neg variable. Okay. Now, if the noise words cannot be the context word, okay, then what will happen if neg not in context, negatives dot append applied over neg, all negatives dot append negatives, return all the negatives. So at the end of the day, the negative all get underscore negative function has been assigned to all negatives. Okay, so we are not considering the negative words under the context. So if that is not, then this is how you can define with the simple if conditions. Okay. Now, first of all, we see the random class generator. Okay. So what I'm doing, this portion of the code I am sending to your comment box. Okay. Please generate these few of the random generator under the range 10. Okay. That means 0 to 9. The original range is 0 to 9. So let me post in the comment box section. Okay. First of all, you just run it, then define the negative frequency and remove the negative frequency from the context. That portion will be done. First, you just run this portion. Then I am posting the next portion of the code where you will define all the negatives, that means noises, and remove it. And the removal has been done, okay, by applying the formula PW for any sampling probability is the ratio of the watt frequency W to the total watt frequency raised to the power 0.75. That is how I applied here while defining the sampling weight. Okay, so counter I to the power 0.75. You can see in this line we have defined for I in range length counter. Kindly let me know if you have been able to run it successfully. Okay, Pankaj Kiswani sir has been able to run it. Okay, rest of the faculty members, respected faculty members, kindly notify me the answer. Okay, thank you, Modip sir. So I am posting now the code of the negative frequency part. Okay, just make sure that all of you have been able to run it correctly. Please check your comment box section. I have posted the negative frequency part. Okay, just make sure that you are running it successfully. Thank you, Aisha madam. Thanks a lot. So that is how you can do the negative sampling. Okay. Okay, thank you. Thank you, Pankaj Keswarani sir. So let me share the screen. So this is how you can incorporate the negative sampling part. Okay. And once you are done with the negative sampling part, just kindly notify me. We shall move to the next part, reading into batches. So I think we are done with the first half. We are done with the first half because it's already 11 a.m. So I'm requesting the organizers that should we stop here or we can continue for some more time and then come back at 11:30. So I am requesting your input.
Yes,
so kindly share your opinion.
You may go ahead, or you can also get a break for maybe half an hour, and then we can return again.
Okay, so
as per your wish, sir. No problem.
Okay. Just let me check if the respected professors are able to run this portion of the code successfully. Then we can. I think it's already 11:05, so we can come back at 11:30. Then we can do the rest of the portion. Okay.
Absolutely. Thank you, sir.
Thank you, madam. Okay. Vivakar Pathak sir, thank you very much. Indomuti madam, thank you. Samira madam, thank you. Okay, Somudip sir and Aisa madam already has done it. So as Subhasri madam suggested that we can take a few minutes break and then we can come back. I think now it's 11:05. So already we have done till the reading into batches. Then we will incorporate this rest of the portion after coming back from the break. So let us take a small break of a few minutes, of 20 to 25 minutes. Then let's meet around 11:30. Then we will incorporate the rest of the portion.
All right. So yeah, with this we come to the end of
Madam, I think your voice is not audible. Some problem is going on in the network. So I am thankful to all the participants for their active participation in the first half. So let us continue that type of activity in the second half also. Okay, thank you very much. Thanks a lot. See you in the second half.
Thank you so much, sir. Thank you.
Thank you very much, sir.
So we request
So
all
thanks,
the
Somadip, sir.
participants. Yes, thank you very much. And we request all the participants to, you can take a half an hour break or you may stay in this link. And the second session for the day will be starting just after, just sharp at 1:30 a.m. So sir will be here and we will start.
That will be 11:30, madam.
So yeah, sorry, 11:30 a.m. Thank you. Thank you very much for the correction. And to all the participants, we are going to start with session 2 from 11:30 a.m. The feedback and attendance form will be posted at 3.
Yes, it will be shared at 3 p.m.
3
just
PM
like
and
yesterday.
Just like yesterday, and it will be
Yes.
live till 3:30 p.m.
all
Yes.
right. So I think I got disconnected. Am I audible now?
Yes, madam, you are.
Yes, ma'am, you're on.
Okay. So I am extremely sorry for the interruption. So as Bhavravi just said, we will be going for a short break, and we would get back again sharp at 11:30. Sir would be here. So I request all the participants to stay back here in the link itself, so that we can begin the next session sharp at 11:30. Thank you.